Hi, I'm Colin Sutherland, Executive Vice President at Geotab, and welcome to Connected with Geotab, where I am interviewing executive guests on trending topics. Our goal with the podcast is to create a connected community where listeners can locate a variety of topics and connect ideas for this fast-paced economic and business climate that we find ourselves in. And today we have with us Jean-Paul Bignol, our Vice President of Business Development, Government, and Smart Cities with Geotab. Welcome, Jean.
Thank you for having me.
Yeah, Jean, thank you. Thanks for making the time for us today. Your journey with Geotab has been about 4 years now, and why don't we just start there? Let's talk about the journey as you entered into the company and where we are today.
Yeah, so it's a little over 4 years I've been with the company. It's been a wild ride, no doubt. I started off, so maybe even pre Geotab. I'm an engineer by education, so I did an engineering degree at Queen's University. I did some further education to that got me exposure to more of the business side of things, which I think has been important to my kind of career goals here at Geotab. And so I originally started as a solutions engineer and very quickly bounced around the organization for about a year and a half. So I started off as a solutions engineer. I worked on a variety of kind of strategic sales activities. I spent some time on the marketplace team. And so I got a really good sense of the value of the ecosystem that we've created at Geotab and how it can be used and positioned within a various fleet opportunities. So that was really exciting to me. I think the culmination of both of those things got me started down the road of working with various government customers. And so that essentially has led me to where I am today. And I think my work as a solutions engineer, my work with the marketplace team gave me a really good sense of kind of the art of the possible, which in turn has translated into working very closely with government fleets and even kind of going beyond traditional fleet use cases, which is really the topic of today's conversation. Going beyond traditional fleet and into more of kind of a smart city narrative, which is very exciting. I think there's a lot of public sector agencies today that are transitioning traditional telematics programs into much broader smart mobility programs, those kinds of things. And so that's where we typically weigh in and try to add value as much as we can. So to kind of summarize, about 3.5 years I've spent dedicated looking at business development opportunities and activities specific to public sector and customers at all levels of government, federal, state, provincial, and local.
Let's try to level set on some vocabulary about smart cities and this thing called ITS, or Intelligent Transportation Systems. I've heard both have been buzzwords around there for longer than 10 years. Some of them were incredibly abstract concepts that people wanted to rally around. Give us your perspective of definition of smart city or even ITS. Are they the same thing? Are they different? And how do you feel about those topics?
Yeah, so I guess I'll start by agreeing with you that smart cities in general is and really always has been a bit of a buzz word or words. It means a lot of things to a lot of different people. When we talk about smart city at Geotab, it's really specific to smart transportation use cases. So just having the pedigree that we do in fleet and transportation in general, there's a lot that we can provide in the form of value to cities, to states, to provinces, even all the way up to the federal government, in terms of transportation insights and things like that. So really Geotab, we're guilty of kind of taking advantage of a bit of a buzzword in the sense that smart city is that. But really when you distill it down, smart city through the lens of Geotab really means smart transportation. And if you take it even a couple layers deeper, most starting points to a true smart transportation plan or smart mobility plan is really high accuracy data collection. And you mentioned ITS, Intelligent Transportation Systems. Most of the initial deployments of successful ITS equipment today are focused on data collection. So let me count vehicles at intersections so I can make more informed decisions with respect to traffic signals, or I can make more informed decisions with respect to growing the overall transportation network, those kinds of things, right? So ITS typically is, it's many different things. But what we come across more often than anything is, intersection connected equipment, using camera vision to count vehicles and specifically turning movements at intersections. What's really interesting is when ITS actually takes it one step further. Instead of just passively collecting data that can be used to inform decisions, it's now also being used to actually control critical infrastructure. So the best example of that would be using computer vision at intersections to dynamically change, traffic signals, to extend green lights, to shorten red lights, to prioritize certain kinds of vehicles through corridors, those kinds of things. And then to kind of close the loop, the reason that's all of interest to Geotab is because we are often, and really more specifically, our customers are passively collecting an unbelievable amount of data on these roads today. So when people speak of ITS, again, they're typically talking about infrastructure ITS projects. Like, what equipment can I put either embedded in the pavement or, roadside at the intersection, those kinds of things. Not very many people think of connected vehicles as a large contributor to ITS. And that's really where we're trying to change that narrative. So we've spoken to many cities who are considering multi-million, in some cases as high as billion-dollar investments in ITS roadside infrastructure. And when you peel back the onion, the insights that they're trying to collect are available today from connected vehicle data, from tens of thousands, hundreds of thousands, millions of vehicles driving around on these roads today, collecting very relevant and very granular information on how the road network's being used. So that's kind of where Geotab fits in. And again, to connect the dots in your initial question, I've always considered Geotab Transportation Insights as a critical ITS subsystem. And then ITS fits in with the smart kind of transportation vertical, which is a small slice of the overall smart city. So it's all connected. We're trying to solve real world problems here. We're really focused on tangible outputs for our customers. And, I see a lot of smart city buzz that isn't always tangible.
Talk to me about the idea of collecting data in real time versus studying all the historic data. So when do we use historic data in order for this type of business development to happen? And how important is the historic data versus just real-time instantaneous data?
Yeah, no, it's a good question. So the best way that I would describe it is it depends on the agency or department that you're working with. So if you're working with a planning department, for example, they're interested in understanding highly aggregated insights. It's really kind of traffic demand volumes. So where are my major commuter arteries in and out of the downtown core? How many vehicles are coming in from the outskirts of a region versus live downtown? Those kinds of things. And that lends itself to more passive or offline analytics. So highly aggregated historical analytics that allow planners to A, justify the decisions that they make, and then B, allow them to make more informed decisions. So they might decide, for example, a really good example that comes to mind is everything that's going on in New York. So New York is implementing congestion pricing. And so the first thing that is being asked is, well, what price points do I set? And how can I effectively change behavior based on those price points, based on the various constituents that I target, that kind of stuff. And so anyone who's involved in that level of a planning project, step one would be, give me as much data as I can possibly get my hands around, because I need to understand the demographics of people that are traveling in and out of the city, what routes they're taking, all those kinds of things in order to make an educated decision around how to influence those kinds of behaviors. So that's when you're talking about like a planning department like that, typically long horizons, the historical data is incredibly valuable. On the operations side, you're typically talking to traffic engineers, traffic signal operators. They need real-time data. They're essentially reacting to incidents and anomalies in the system, accidents, all kinds of things. And so they need to be aware of things before, they get a citizen complaint or before police get notified of an accident, those kinds of things.
So let's talk about traffic light sequencing. You just raised the topic, and I know we've got projects that you're actually quite passionate about, traffic light sequencing. I think we probably, myself or you or everybody listening, has had that experience where you're driving up, green light, and all of a sudden it turns yellow. You come to a stop, and the next light's going to be yellow and turn to a red. You just miss the sequence, and I'm sorry, the next 5 lights you hit, you're out of sequence, man. You're going to be hitting all those red lights, which is costly on fuel. It just frustrates us as drivers. So first question I've got for you is, in order to build the models, is there a distinction or value to fleet vehicles populating those traffic business models versus consumer vehicle traffic? Is there actually a distinction when building out those business models? And maybe you can talk to us about the journey down in Nevada that we're doing with traffic light sequencing today.
Yeah, so I'll start. I'll actually answer the Nevada. Well, I'll start with the Nevada story. So we've done some really interesting work with RTC, the Regional Transportation Commission of Southern Nevada, who operate basically a lot of the road networks in the southern part of Nevada. So their main focus really is Las Vegas. And in the work that we've done there, we've uncovered some really interesting things with respect to specifically traffic signal operations and prioritizing. So I'll back up a little bit. If you're a traffic signal operator, your job is kind of twofold, and many would argue more than that, but there's 2 major priorities for you. You need to move vehicles as efficient as possible in a region. And oftentimes you have very specific KPIs to meet. So in the morning and afternoon time, you want to move consumer vehicles. You want commuters to get to and from work as efficiently as possible. And then there might be some other, like there might be an intraday. So in the case of Las Vegas, there is a large proportion of commercial vehicle movement to and from the Strip. And you can imagine these are deliveries, these are cleaners, these are all kinds of people that are taking advantage of an intraday lull. So you get very distinct traffic profiles based on time of day of week, those kinds of things. And so what we were able to expose in Las Vegas, and we've been able to replicate elsewhere, is traffic signal operators traditionally use like these signal progression models that take into consideration average traffic speeds. So take the midday commercial vehicle rush hour, if you can call it that, in Las Vegas. So we've all been on Las Vegas roads. When I say it's a commercial vehicle rush hour, there's a lot of commercial vehicles on the road moving to and from the Strip, but the consumer vehicles still represent the majority. So if I take a statistical average of speed, my commercial vehicles are going to be almost skewed out of proportion by the faster moving commuter vehicles. And the reason that's important is if you're trying as a signal operator to prioritize the movement of commercial vehicles to and from the Strip, and we know that the commercial vehicles move a lot slower than the consumer vehicles, then you have to consider that when coordinating your traffic signals. So what we found in Las Vegas was interesting was if you just take average road speed and say, I'm going to set up all my traffic signal delays based on average road speeds, you're essentially prioritizing fast moving light duty consumer vehicles. And when you have a commercial vehicle rush hour, and commercial vehicles being large, slow moving typically, they actually, they run into a scenario like you explained originally. They hit all red lights. They cannot keep up with the lighter duty faster moving vehicles, and they hit red lights the entire way. We actually showed it in the data. They had prioritized incorrectly in very specific corridors. So that's really the value of this data, is to be able to get very granular insights, not only on just like what's the average speed, but what kind of vehicles are you looking to prioritize, and how are they moving differently than maybe some of these other modes of vehicles that you're not trying to prioritize. So it's a really interesting, again, going back, like we're trying to solve real problems. It was a really, really interesting project that is ongoing with RTC. I give them a lot of credit for kind of uncovering these issues and trying to, I guess, push the envelope in terms of adopting connected vehicle data in their kind of organization. And so we're scratching the surface. We're learning a lot as we go, but it's a really good example of how this data can be used and how it can in turn drive a whole bunch of downstream value, and more so for local constituents, right? Because every time a slow moving vehicle hits a large slow moving vehicle hits a red light, the light duty commuter vehicles queue up behind them. We've all seen it. You're stuck behind a Class A tractor trailer, and you're just waiting for them to go from red to red light. So, and then I guess just to circle back to your initial question, that in and of itself is incredibly valuable. That insight is incredibly valuable for our fleet customers. And so if you pick a large carrier and you service the Las Vegas Strip, you should be aware that RTC is trying to actively prioritize the movement of your vehicles to and from the strip, and we're trying to help them do that. And so that's where the benefit comes back to the fleet, because stops and starts are incredibly expensive in terms of wasted fuel, and not only that, wasted time waiting at red lights is incredibly valuable as well. So that's this concept of, how can we help the broader customer ecosystem? How can we help them be more efficient in Las Vegas, getting products to and from the Strip? And RTC has been a great partner in doing that.
So when we're talking about, that's a lot of historic statistical modeling, and RTC is able to do that. Let's talk about vehicle to infrastructure. And is it possible, or have you examples of where on a real-time basis, a traffic light may go red, green because of the vehicle that's approaching the intersection? Let's take an example of a first responder. Well, we don't want first responders hitting red lights. We want to make sure that if they are going through an intersection with a red light on, their sirens are going. That's not 100% safe. It would be nicer if the red lights were in the opposing traffic. Got any examples of vehicle to infrastructure, and where do you see, is this actually a vehicle to infrastructure thing? Can we actually allow RTC in some cloud-based area to do traffic light sequencing in real time? Is that actually also considered vehicle to infrastructure?
Yeah, so that's a really good question. So I'll start almost from a historic perspective. The way so there's just dumb intersections that they're on a time sequence, right? And they just roll through lights, whether there's no smarts to it whatsoever. A lot of governments have invested in vehicle detection technology. So typically these are either embedded in the pavement itself. So the concept of an induction loop sensor that can sense a vehicle over top of it, and in turn actually change the signal phasing of a light. That's been around for a very long time. They're typically very expensive, and they're not overly smart, but they're smart enough to detect a vehicle and maybe change the way the light behaves. I think what you're more alluding to is some of the newer concepts, and they're actually more than concepts, but some of the newer technologies that are focused on V2X, and in this example specifically vehicle to infrastructure communications, right? So the concept of can a police vehicle that's approaching an intersection actually request an extended green light? And that does exist to a certain extent today. There's technologies, primarily RF technologies, that allow a police vehicle approaching an intersection to actually request a priority via radio frequency to the intersection. I think what's even more exciting is there was a lot of, and this is in flux, but DSRC, which is like a Wi-Fi spectrum. There's a lot of work around DSRC to enable vehicle to vehicle and vehicle to infrastructure communications. The same is true with, they call CV to X, so cellular V to X, which is it's a competitive transport technology, but the underlying kind of framework is exactly the same. How do I enable ultra low latency communications between a vehicle and its surroundings? So initially a vehicle and another vehicle, and or a vehicle and the intersection. And then there's all kinds of other concepts like a vehicle and the charging station and really anything in that vehicle surroundings. And so the concepts, the more mature concepts around V to X, they do suggest there could be a point in time. And in fact, actually one of the most interesting articles that I read was, if V to X becomes what some think it will, so if it is truly proliferated in every vehicle, so imagine a point in time where every vehicle is speaking to one another and they're communicating predominantly safety messages, basic safety messages. So I'll be driving down the road and calling your 5 vehicles ahead, and you lock your brakes on. My vehicle will know that you, 5 vehicles ahead, has locked your brakes on before I see a single brake light. So that's critical, right? Like, your vehicle is able to react to information way before we as humans behind the wheel could ever react to it. So a lot of safety, a lot of really interesting safety use cases. But from a traffic management use case, I read an article and it was, if we ever reach a point where all these vehicles were connected with V2X technology and they were able to communicate with one another in real time, ultra low latency, do we need traffic signals? Or can the vehicles negotiate the intersections amongst themselves? So I'm approaching an intersection and you might be approaching an intersection from a separate direction. You know my trajectory. You know exactly when I should arrive into that intersection. You could literally speed up or slow down to miss me by 2 feet. Do we actually need a signal telling us, this direction go, this direction stop? So there's all kinds of super interesting use cases for this technology. I think it's still very, very early days. The biggest challenge in the next 10 years is going to be, we've got to reach a certain economies of scale where, like 99% of vehicles have this equipment, these electronics embedded. But once you get there, there's some compelling cases for some really transformational traffic management type use cases. Really, really interesting stuff.
Yeah, indeed. We get to travel different places of the world. In some places of the world, there are no traffic signals, and drivers are negotiating lanes and intersections, and of course, roundabouts. Those are all things that are very efficient. In the UK, you see roundabouts all the time. Very efficient way of cars moving to the inner and to the outer side in order to go and negotiate without having to come to a complete stop at a traffic light. So that's a low-tech solution to keeping vehicles moving, obviously. I think what I want to talk about is the reality of the abstract nature of smart city or ITS. Smart city and ITS have been around as expressions for well over 10 years. And there have been conferences structured around them. Come and listen to a speaker talk about smart city, and you go, and it's very abstract, very future. We need infrastructure. We need 5G before any of this moves forward. It does sound like the work that we're doing with RTC and traffic light, the traffic light planning is real world. It's happening today. How close do you think, or do you think that this is a bona fide next step into actually not making it abstract, but making it a practical way that all cities could start planning and working on data and traffic flows and then moving forward? So is this still an abstract early beta concept, or is this actually production?
Yeah, so it's a really good question. And I think honestly, everything you said there, I've been to a million of these smart city shows, a million of these intelligent transportation shows. everybody focuses on the sexy, abstract, like the story I just gave. The time, the point in time when vehicles negotiate the roads on their own, right? That's a cool concept. But let's be honest, it is nothing more than a concept. What not enough people talk about, and I always, when I'm invited to speak at these various conferences, this is always kind of the point I try to make right up front is smart city shouldn't be sexy, or at least it doesn't have to be. Like, there's a lot that we can do today with all kinds of various technologies, most of which are on our roads today. Like, connected vehicles are an amazing source of ITS data. We don't need to roll out incredibly expensive, complex roadside infrastructure projects and layer the whole city in high-speed fiber and put 400 sensors on every street light. Like, that's part of the problem, I think, with smart city today, is there's this conception that, can you write a check for $10 million and that'll get you started? And that's just, quite frankly, wrong. Like, there's a lot of data sources today. There's a lot of things that we can do with existing technologies on the road. There's a lot of even infrastructure, like roadside infrastructure, that can be used to generate substantial, quote unquote, smart transportation initiatives within any region. I mean, we're showing that in Las Vegas. Another really cool example was in the city of Detroit. So in the city of Detroit, when everyone talks about V2X, they're always the typical use case, at least the only use case that really gets any airtime, is safety focused. So how can we reduce the number of traffic related injuries and fatalities? How can we make it so that when a pedestrian is going to walk into an intersection, those vehicles approaching that intersection hit the brakes? And so in order to do all of that, you need ultra low latency, millisecond latencies. You need vehicles communicating with one another and the infrastructure with millisecond latencies. But there's a million use cases that aren't safety focused that don't require millisecond latency. So in Detroit, our goal, we partnered with a company called Myovision, who you're familiar with. They do smart intersection technology. They had some equipment distributed across the city of Detroit. It's a big customer of theirs. And so we contemplated whether we could do a cloud-to-cloud integration, Geotab communicating over LTE cellular, and then LTE cellular back down to Myovision. So essentially the loop was Go device, cellular to the cloud, Geotab cloud to Myovision cloud, back down cellular to the intersection. The overall latency in the loop was like 10 to 15 seconds. Could we prioritize freight vehicles along a specific corridor using this kind of integration, a true cloud-to-cloud integration? And what we found was we could. So we enrolled one of our larger freight customers in the pilot. We developed the integration such that when these vehicles approach the intersection, they would request an extended green light, and they would do the whole thing over cellular and cloud to cloud. Latencies were 15 seconds. We stood the whole thing up in less than a week. Zero cost on behalf of the city, all legacy technology. And we demonstrated true freight signal priority in the city of Detroit. It was amazing. And that's, again, like, that was without spending a penny. These are existing technologies in place all over. And you could do the same thing just about anywhere in the country. So really kind of, not super sexy, but nevertheless high value use cases enabled using existing technology that don't require $10 million investments on behalf of the city.
So for any city that has a port, if you happen to be on the water, or even a rail switching yard with intermodal containers being pulled off the back of a freight train and being dropped on the back of a flatbed for trucking, where does that truck go? Often those intermodal yards were at one point on the outskirts of town, but now cities have grown, and now sometimes those rail yards are right in the middle of the city, and now you've got these trucks with containers on the back. and we don't want them driving down the wrong city streets, right? So it's an interesting use case that was developed with infrastructure. And that's for city planners. And the encouragement that you would have is like, talk to us about your congestion problems, your vehicle challenges, whether it's time of day, fleet class size, what class roads or what class vehicles driving on. Those are the types of problems that I guess your team is coming across.
Yeah, 100%. And I think, again, wrapping your head around the fact that you do not have to go to city council and allocate a $10 million budget to get started, to find out where you may or have issues. That's the piece that we're constantly advocating for. Like, there's a lot of sources of this information. Typically, that's not to say there won't be a $10 million check, but at least you can justify that $10 million check with some upfront analysis and insights across the road network. So yeah, that's a major kind of message that we push specifically within our city fleet customers, our large city fleet customers. Port activities is a perfect example of you can do all kinds of ITS focused work within ports without actually deploying very expensive infrastructure. So yeah, for sure, it's a very good point.
Let's talk about something on the more personal side that you're passionate about, which is Vision Zero, or Together for Safer Roads, which is an association that we're members of. Why don't you just reflect on, or maybe even talk about what Vision Zero is, or Together for Safer Roads is? What's the mission and what's your passion in this area?
I mean, Together for Safer Roads is a great kind of partnership consortium we've been part of for a very long time. I mean, if you think about Vision Zero and Together for Safer Roads, and really all the various partner companies that are involved in Vision Zero, we all really have one focus, and that's to reduce and hopefully one day to even eliminate traffic-related injuries and fatalities. It's a massive problem globally. It's unfortunately a very, very large problem here in North America. And so and typically, again, our work with TSR and others is directly along the lines of the previous conversation we just had. Is, if you want to be a Vision Zero city, of which there are many here in North America, and there are some unbelievable stories. The top of the list is the work that New York City is doing with their Vision Zero program. And I point to New York City as a constant example to other cities that are considering adopting this, because in my opinion, they've done a fantastic job maximizing results while minimizing investment requirements. So again, like directly along the same lines of that previous narrative, they are using data sources across their telematics program. They are leveraging relationships with local universities and colleges to do data science work. They have all kinds of, they actually partner with a lot of the local fleet operators. And they've created this environment where everybody is kind of contributing to a pool of data and a pool of knowledge that helps the city reduce and eliminate traffic-related injuries and fatalities. They've got a great story on their website about it. Vision Zero Network highlights their efforts quite often. The work that we specifically are doing with the city outside of the telematics program that we have is helping them understand, again, using aggregated data from multiple sources, helping them understand like the effectiveness of traffic calming initiatives, for example. So New York City is constantly redesigning their road network through a safety lens. So, and it's often balanced with like a traffic efficiency narrative as well. But from a Vision Zero perspective, their number one priority is reducing traffic-related injuries and fatalities. So they're redesigning roads to narrow lanes to slow vehicles down. They're extending soft medians into intersections to widen left-hand turns. They're doing all kinds of things in hopes of, incentivizing people to drive safer and in turn, hopefully, reduce the number of incidents they have out the other side. And so what we're doing is helping them understand in the real world the effectiveness of these efforts. So when they narrow a lane on a targeted road, the way New York City historically, and I would argue most cities in North America, even globally, the way they monitor the effectiveness of that change is they send students out with radar guns. They have car counters. You know what I mean? It's easy pass data, that kind of stuff. And it's a soda straw view of what's happened. And so they might have achieved a speed reduction target on that specific road. And that's honestly, like, that's in many instances, unfortunately, where the effort stops. We achieved our goal. Good for us. The problem is the whole system is coupled. So you may have slowed vehicles down on that targeted road, but they might now be cutting through a school zone. And that's worse. So that's the kind of work that we're often doing, right? Like when you put speed bumps on a residential road, sure, vehicles are going to slow down. But what might be nastier is what if they're avoiding that road altogether now and they're taking, like I said, like they're cutting across a school zone or something even worse. So we're helping them get like the 30,000 foot view of these kinds of changes and help them understand not only whether they're achieving the desired impact on the targeted road, but what kind of changes are rippling across the rest of the transportation network. And again, it's a really good use case for connected vehicle data. There's not too many technologies that are in existence today that would allow you to take a 30,000 foot view across the entire road network. So powerful stuff. And if I would encourage anyone to go to their website. They're saving hundreds of lives a year in New York. It's really amazing work they're doing.
So I know we're wrapping up our time together, Jean, and I know that you've got some young ones at home. And as you have young ones at home, and we're here in almost July 2020, it'll probably be 2030 plus when your youngest actually gets their driver's license. What do you think that's going to be like? Do you actually imagine your children having driver's licenses? And what kind of future world would you hope that they're going to be driving on?
Yeah, I mean, I'm not going to I think back, I figured we'd all be in flying cars by now. And so I think these kinds of evolutions take a lot longer than anyone really likes to think. And I'm a believer of that. I think the whole autonomous vehicle movement is going to make considerable strides. But I think those considerable strides are going to come in like level 3 and 4 autonomy, where you still require a driver present and able to take control of the wheel. Level 5 autonomy, I think true level 5 autonomy is going to be difficult unless, and I think this is another thing, like I think the government's going to have a major influence on where this all goes, because if the government starts allocating designated autonomous vehicle lanes, it's a very different story. It's almost like light rail concept, except more free flow. So the government has the ability to either pour gasoline on the fire or do the exact opposite too. Like I think if without some kind of government intervention to really enable some of these technologies, I think we're going to be stuck in the level 3 autonomous vehicle space for a long time, which is still amazing. Like, that would mean my kid most of the time isn't driving, and hopefully the vehicle is reacting to the environment much quicker than he would on his own. I think the other thing we're going to see is hopefully a bit of a resurgence of like public transit. And so I'm optimistic governments and private industry are going to crack the whole last mile nut. And instead of my son taking the car in the parking lot and taking it for a drive, he's going to get picked up in, I don't know what it is, Uber today, who knows what it'll be in the future, and he'll go to the bus station. The bus will take him from this true multimodal smart mobility type stuff, I think is real. And I think it's much closer than a world where private vehicle ownership remains high and everyone's got level 5 autonomy.
Jean, thanks for your thoughts today. And we didn't mention the fact that you've authored and your team has authored some fantastic white papers in this area, whether it's from traffic light sequencing or just thought processes on just fleet ownership and smart city development. So I would welcome anybody who's listening now to go to our blog posts or our community site, download those white papers, reach out to Geotab. You can do that through our community website, community.geotab.com, or by researching our blog and staying glued and all those developments that we have at the company that are really here, which Jean, I think, has done a great job of discussing today, is taking that abstract world of what is a smart city, but really brought it down to practical, real world. Let's get started now without major capital investment. So thanks for all those insights, Jean, and welcome our listeners to go and join those white papers and blogs and community site. And we want to thank you, and we want to look forward to the next episode of Connected with Geotab. Jean, thank you for your time again today, and thanks everybody. We'll talk again soon.
Thanks, guys.
Thanks, Jean.